So in this video we're going to demonstrate using a silver braze 55T to join copper to stainless. We've demonstrated already in another video how to make a flux, which we have to use for an application with a silver brazing alloy. The flux is used to chemically clean the joint and to make sure that the silver braze flows around the whole joint. But like all good brazing, it starts with cleaning everything. I've pre-cleaned this, but with a piece of emery, a sort of webbing emery that we use, you clean off both inside and out. Although the braze is going to be predominantly on the outside and on the end, it's good practice just to clean it on the inside and the outside. And then again, although this piece of stainless is fairly clean and tidy, we're going to give it a bit of a rub just to make sure that we remove any oxide films or contamination, greases and things like that are on the surface. It also keys the surface quite nicely for the silver brazing alloy to join to the stainless and the copper. And what's happening with the brazing is you are not joining the two together, you are using a third-party material to join to the copper, a third-party material to join to the stainless, and the strength of that joint should be as good as the two materials themselves if we do it right. So I'm going to put a little bit of solvent on, get a rag, a little bit of solvent on, or you can use any non-oil based degreasant, just to give that a good clean, make sure we've got everything. You can see, even though we've rubbed it with some emery, there's still a bit of outstanding muck on there. So we're giving it a nice clean there. Do the same with the end of the piece of copper. And like all good brazing practice, getting it clean is the most important part of it. So we're going to just join that copper tube onto that piece of stainless. In this application we're going to use a domestic, readily available from most DIY stores, plumbers, merchants, things like that. It's a propane based gas burner. Not ideal for using this, but just wanted to prove you can use this and do the job, albeit it takes a little bit longer and you have to be a bit more patient with getting it up to the heat. So first things first is to apply some flux. So what we're going to do here, again, we've made up a nice creamy paste of the flux. We're going to just paint that on in a simple circle in the middle where we want it to go, and just create a blob. Again, the outside here of the copper, a little bit on the inside, and just make sure there's some on the end, which is where the joint's going to be made. And then we're going to put that on top. There we go. So applying the heat, burner on. Oh, there we go. So as we apply the heat, we're going to apply it all the way round as best we can. You can see the bubbles where actually that's just the water made up with the paste boiling off. So we're not activating the flux yet, we're just purely boiling off the water. So that now is most of the material, that's the water burnt away. So it's left the flux powder, and you can see where I'm applying the heat, where the flux is, it's the ring of copper colour where it's preventing the oxygen getting onto it. Above that you can see the line where the oxygen is actually reacting with the material, the copper, and that wouldn't allow the joint to take place. So we've got to try and heat up the whole thing all the way round in a nice uniform way to a cherry red is what we're sort of looking for in an ideal world. And this is where, with this type of a torch, you need to have a bit of patience. Now you can see the flux has started to go a glassy colour, or a glassy filmy application, and that's it starting to activate. So we're starting to get up to roughly the right temperatures. But I'm going to keep applying the heat. This being copper is a very good conductor of the metal, of heat. So it's actually conducting the heat away from the joint up the pipe. So we need to keep making sure we apply plenty of heat. And then I'm going to aim it at the steel base plate. And what we try to do is apply the heat on we put the rod on the opposite side of where the heat's being applied, and we encourage the brazing alloy to feed round. That's not quite warm enough yet. You can see it's cherry red on the back there. And we're starting to get there now. We've got to keep it moving, and then hopefully, if I apply the brazing alloy, it'll suddenly, when it gets, there we go, it's gone there. And you can see it's worked its way round to where the heat was. And that's all you need, just a small amount. We'll leave that just to cool down. We don't want to cool it too quickly because you can thermally shock the part. So I'm going to just go and get a pair of tongs, and then we'll give that a wash off and get rid of the fluxes. And then we're just running this under a tap just to cool it down so we can handle it. It's always a good test you've done it right. When the water stays in, it doesn't come out through the gap. So, and then what we're going to do is clean any old flux residue. The flux is a chemical cleaner, and if it's left on, will actually start to corrode and eat away at the metal. So making sure when you've done any braze joint that you give it a good clean with a mechanical wire brush, or even just a bit of emery like this is. This is an emery webbing, which has got no paper backing, so it's really good in the wet. So here we've got the copper tube that we brazed with our Silver Braze 55T brazing alloy to a piece of stainless. The joint should be as strong as the parent metal, and in some cases stronger. So we're going to give it a bit of a test. Just check the vise is nice and tight and give it a good bang. And try it that way as well. Get it nice and close to the joint. And we should be able to give this a hit, and at no point has the braze joint actually broken.